All right, hey everybody. My reaction that I'm going to be going through today is bromocyclopentane reacting with sodium methoxide and a DMF solvent. Specifically in the scenario of SN1, SN2, E1, or E2 reactions. When I look at a problem like this and I'm not sure where to start, I always like to start by looking at the reactant, in this case bromocyclopentane. Now for these types of reactions, the main thing that we're concerned about is the type of carbon that we'll be reacting on, the alpha carbon. Our alpha carbon is right here. In this case, our alpha carbon is secondary, which means it can undergo any of these reactions. It can go through SN1, SN2, E1, or E2, which isn't super helpful. So next, let's look at what it's going to be reacting with. In this case, that's going to be the sodium methoxide, more specifically, just the methoxide ion. Now, the methoxide ion is a strong base. If you recall, the pK of methanol is around 15. It's a strong nucleophile. And it also has a -1 charge. It's negatively charged. All of this tends to favor an SN2 or E2 mechanism. Since we have a strong base and strong nucleophile, I tend to think of these as quote-unquote more reactive or more willing to react than, say, we had the pronated form of methoxide, methanol, which would likely react versus solvolysis, and we would go through SN1 or E1 instead. The next part is looking at our solvent, which in this case is DMF. Now, if you don't remember the structure of DMF, I'll draw it out right here. Specifically, the most important thing to note is that this is a polar aprotic solvent, which favors SN2 and E2. The reason being is that when we don't have a proton to donate to a strong base or strong nucleophile, it has a hard time solvating that. So this methoxide will stay as methoxide, and we won't have any of it lost as methanol. If we had a protic solvent, then this methoxide could become methanol, and then we might react via solvolysis and get closer to some SN1 or E1 products instead. But since we have both a strong base and strong nucleophile, negatively charged, and a polar aprotic solvent, we know that this is going to go through an SN2 or E2 mechanism. So let's go ahead and cross off SN1 and E1 and draw our products. Now, we know there's going to be a mixture of both. Here's our E2 product, and this will be our SN2 product. The important thing to note when we draw the SN2 product is that the stereochem has to be inverted. Since we don't go through a carbocation intermediate, you know that you have to go through backside attack. So the stereochemistry is inverted. Now, if you were to ask me which one of these I think is the major product, I would probably say the E2 product. Now, I like to think of basicity as a subset of nucleophilicity, i.e., it's donating its electrons to a hydrogen rather than just to any electron deficient center. In this case, since methoxide is such a strong base, since methanol is such like a weak acid, I would say that the E2 product will be favored, but maybe not by much. You'll get a mixture of both products